Hey Trig students, in this section we're going to be looking at angle relationships in similar triangles. Again, it's a review, like I said in the last section, of things that we have learned already in geometry. So that's where we're going to look, here we're going to look at geometric properties and triangles, similar triangles to be exact. We should know what vertical angles are. Vertical angles have equal measures also. That was one of our, well, yeah, let's see. Okay. Hey, trigonometry students. What we're going to be doing in this first lesson is Chapter 1, Section 1. And this is going to be mostly about angles. And first of all, we're going to start out with talking about basic terminology. Then we're going to go to degree measures, and then something called standard position, and then coterminal angles. Let's get started. Some basic terminology that we should know already is this right here. Two distinct points determine line AB. So if we have this drawing right here, and we see that this line extends on forever in both directions, then we should know that it is indeed a line. And how we name the line is by the points that are on that line. In this case, we only have 2 points, AB. Name it that, line AB. Now, this drawing down here is known as a segment because it's just a portion of a line and it doesn't extend on forever in either direction. It ends with these two endpoints here, A and B. So this is called line segment A, B. Now this one down here, this drawing, is a ray because it has an endpoint and then it extends on forever in one direction. And we're going to call this ray AB, and we call it AB because and not BA because our first point, our endpoint is A. Excuse me. And then extends through B. So that's why we start with A and end with B in the naming of ray AB. Some more terminology. An angle consists of two rays in a plane with common endpoint. That common endpoint right here is called the vertex. Okay? And then two rays, the two rays are the sides of the angle. So these two rays are just known as the sides of the angle. An angle's measure is generated by the rotation about the vertex. So this side right here, we're going to call that the initial side. And then when we rotate that from the initial side in some direction, we call the other side of our angle the terminal side. And this will let you know which way we are rotating the arrows. And that matters because of this next slide. Depending on which way we rotate that terminal side, it is going to give us a positive angle or a negative angle. A positive angle is when we rotate that terminal side counterclockwise. And then we get a negative angle when we rotate it clockwise. The most common unit for measuring angles is the degree. And we'll be looking at degrees for the most part in trigonometry. I almost forgot we were doing trigonometry. I almost said geometry. But anyway, in a complete rotation, so a complete like full circle is 360 degrees. And 1 degree is just 1/360th of a rotation. Okay, so those are some common things that we should know, and especially this right here, one rotation is 360 degrees. Okay, so if you hear rotation or 3 rotations or something like that, then that's 3 times 360 degrees to get the amount of degrees that you are looking for. And you'll see that in our very final problem that we look at in this section. All right, degree measures. Angles are classified by their... All right, for our first example, we are asked to find the complement and supplement of a given angle. So, for an angle measuring 55 degrees, find the measure of its complement and its supplement. If you remember from geometry, we have learned that complementary angles add up to 90 degrees and supplementary angles add up to 180 degrees. So let's go ahead and figure these problems out. So for complement, what we're going to do is say 90 degrees minus our given angle measurement, 55 degrees, and that is equal to 35 degrees. So the complement of 55 degrees is 35 degrees. And then similarly, we do the supplement, except supplementary angles, like I said, add up to 180 degrees. So we take 180 degrees and subtract our given angle measurement, 55, and we get 125 degrees. So these two angles are supplements of each other. Now for this next one, it asks us to find the measure of each angle. So here's the figure that we are looking at. We want to find the angle measurement for this angle and for this angle here. But first we must find what r is equal to. Notice that these angles will add up to 90 degrees, so they are complementary. So what we're going to do to find r is set an equation up again and say 2r plus 3r is equal to 90, and solve for r. So we get 5r is equal to 90. R is equal to 18. So now that we have r, we just need to substitute that back in for here and find our two angle measurements. So 2 times 18, that will give us one of our angle measurements, which is 36 degrees. And then the next one, 3 times 18, it gives us our other angle measurement that we are looking for, which is 54 degrees. And there we have it. The two angle measurements of here and here are 36 and 54. And notice these both add up to 90 degrees, which that is a good case there. That's what we're looking for, two angles that add up to 90 degrees. Okay, for the next example we're going to be looking at is this right here, similar to the last one, except these two angles add up to 180 degrees because they are supplementary. Let's do that one. So just like the last one, set up an equation that's 7t plus 2t, okay, is equal to 180. And then now solve for t. So 9t, okay. My pen tool isn't quite working very well. Sorry for that. So 9t is equal to 180. And then divide both sides. We get t is equal to 20. And just like our last one, substitute that 20 back in for each of these, and we get our two angle measurements. So 7 times 20 is equal to 140 degrees. And then there, it looks more like a multiplication sign there. Anyway, now 2 times 20 is equal to 40. And there we go. If we add these two up, you'd see that we do have 180 degrees for the total measurement right there. All right, next one. All right, so something we have learned in geometry, we have looked at degree measurements, but we've never looked at minutes and seconds before. Um, Minutes and seconds are part of degree measurements. They're just uh, they are a smaller measurement of degrees. Like you see here, it says 1 minute is 1/60th of a degree, and then 1 second is 1/60th of a minute. So this is kind of how things work right here. When we are converting from um, minutes to degrees, um, this is the conversion right here from minutes to degrees. And then if we're converting from um, 2 degrees, then sorry, back to minutes, we have this right here. 1/60th of a degree is 1 minute. Now, same thing kind of goes with seconds, but 1 second is 1/60th of a minute, or you can say 1/3600th of a degree. So whenever we're converting to decimal degrees, you'll see this applying um, right here, these two things right here, this 1/3600 and then this up here. But I'll show you how to convert between decimal degrees and degrees, minutes, seconds. And remind me in class, I will show you how to do this next problem on your calculator too. Okay, like I said, we're going to perform calculations that are in degrees, minutes, seconds. For this first one, it's just in degrees and minutes, and so is the second one, part B. So less calculating for us to do. But here, what we're going to do is to add these two together, we're going to just add together the degrees portion together, and then add the minutes together, and then see if we can simplify it any further. So here we get, when we add 28 degrees and 36 degrees together, we get 91 degrees. And then the 35 and 52, we add those together, we get 87 degrees. Or sorry, minutes. Now 87 minutes is a larger number than 60, and we want this as simplified as much as possible. So we have another degree in here is what I'm saying. So what this is like saying 91 degrees plus this right here, the 87 minutes, which is same thing as saying 1 degree and 27 minutes. Okay, and then add together that, we finally get 92 degrees and 27 minutes. Okay, sorry about my pen tool, it's not quite writing properly. Okay, but y'all can see that, I bet. Anyway, let's go on to the next one. We have 180 degrees minus 117 degrees and 29 minutes. What we need to do here in this case is change our 180 to 179 degrees and 60 minutes. So we have minutes to help us in subtracting this appropriately. So 179 degrees and 60 minutes. I'm going to do this vertically. Subtract 117 degrees and 29 minutes. Anyway, Let's try that. Okay, when we subtract the minutes, we end up getting, what do we get? 29, no, 31. 31 minutes. And then what's left over from 179 minus 17, we get, let's see, 62 degrees. Okay, so there we go. That is our solution for this calculation in part B. 62 degrees and 31 minutes, if you can't read that very well. Okay, so what I'm going to do in this next part, we are doing some conversions. We are asked to convert the degrees, minutes, seconds to something called decimal degrees, which is this right here. This is decimal degrees. This is degrees, minutes, seconds. See the difference? And so we're converting this to this form down here. And I'm going to just show you on the calculator. I'm going to use my little emulator and show that to you right now. Okay, so let's turn this on. So what I'm going to do is I'm going to put in, make sure you have your mode in degrees. Okay, so once you've done that, let's do this. Put in 105, and then you're going to have to go to hit second and then apps. That goes to angles. And you're going to put in, there's degrees, and then here number 2 is minutes, and then where you find seconds is actually down here. You can find it in your catalog, but this is an easier button, quicker to do. Just hit your alpha key and then the plus sign. That will give you seconds. So degrees, and then 20 minutes and 32 alpha, the plus is seconds. Just hit enter and voila, there you go. Our solution is 105, which it should be 105 degree, 0.342 repeating degrees. So just cut that off at 105.342 degrees. All right, so that's going to be the answer for part A. Now part B, again, I'm going to show you on the calculator. Right here, go back to second apps. This will convert any decimal degrees to degrees, minutes, seconds. That's what that means, DMS, degrees, minutes, seconds. Let's go back to that home page and put in 85.263. Again, remember, put this in degrees, in your degree mode. Once your mode is in degrees, it stays in degrees unless your calculator's memory or something is reset or batteries die on you for quite some time. So go back to your apps, well, second apps, and go to number 4, hit enter. You're converting that to degrees, minutes, seconds. Ta-da, there it is. So what you're going to write down is not the 85 degrees, 15 minutes, and 46.8 seconds. You're going to round this last number for me, okay? Because I just want it in degrees, minutes, seconds. No decimal numbers. So your answer is going to be the 85 degrees, 15 minutes, and 47 seconds. Okay. Let's look at this next part here. We have an angle is in standard position. Here's just another term that we're going to be looking at. So standard position is known as this. If the vertex is at the origin and the initial side is on the x-axis, and it doesn't matter where your terminal side is, just as long as the vertex is on the origin and the initial side is the x-axis, this angle right here is in standard position. Now, quadrantal angles, we will look at those further a little later on. but this is what a quadrantal angle is. When we're looking at the XY coordinate system and drawing angles on it, um, all of the quadrantal angles are going to lie along the X and or the Y axis. So angle measurements like here's your initial side, and then say your terminal side. Let me get my pen tool out. So you have this. Well, that is a 90-degree measurement right there with your X and your Y axis. That is a quadrantal angle. So same thing goes with your X axis if you extend it out this direction. This right here is 180 degrees. That there disappeared on me, is also another quadrantal angle. If you keep on rotating around, you will come to 270 degrees. And then if you keep rotating around even further, you're back at 360. So those are quadrantal angles. Now, coterminal angles, here's another term that you'll need to definitely know. We'll be using coterminal angles in another chapter. But a complete rotation of any result in an angle measuring 360 by continuing the rotation, angles of measures larger than 360 can be produced. Such angles are called coterminal angles. So let's look at these examples real quick of these pictures of coterminal angles. Here we have a 60-degree angle measured. In that, we could go 60 degrees, and then if we rotate another 360 degrees, we're back at the same angle measurement, but we have a multiple of that one by it extended 360 degrees more. So that right there, those two, 60 and 420 degrees, are coterminal angles. If the two measurements differ by a multiple of 360, then they are coterminal. Look at this other one right here. We have, see here in blue, that is a 110-degree measurement. But if we keep going further, if we go around this twice, so rotate it another 360 degrees twice, we have this degree measurement, 830 degrees. Well, these two angles are coterminal because they differ by a multiple of 360. Okay? Okay, so we're going to be looking at coterminal angles and finding coterminal angles of a given angle. We're going to be asked to do this. So it says to find an expression that will generate all angles coterminal with a given angle. Add integer multiples, so of 360 degrees to the given angle. So for example, if we are given, we want to find all angles that are coterminal to a 60-degree angle right here. This would be the expression right here. 60 degrees plus some integer number times 360. That will generate any and all angles coterminal to 60 degrees. So, in this one, this example here, it says find the angles of least possible positive measure coterminal with each angle. So what we're going to do here in this case is we want this right here. It says least, let me get my tool out. It says least possible positive measure. Okay. Well, that means our angle that we are trying to find that is coterminal to each of these is going to be between 0 and 360. So we are going to either add or subtract 360 as many times as we can to get to an angle measurement that is coterminal to one of these that we are given, that's between 0 and 360. So for this first one right here, sorry. So for this right here, we are going to subtract 360 3 times. I know that because I've already figured this out for myself. But let's do that and see what we get. So take the angle measurement given, subtract 3 times 360, and we end up getting the measurement of 26 degrees. That is a degree symbol. There we go. So these two angle measurements, the 1,106 degrees and 26 degrees, are two angle measurements that are coterminal because they differ by a multiple of 360. So that's what we're trying to find. It's just the least positive, or yeah, least possible positive measure. That's hard to say. But anyway, let's move on to part B. We do the same thing, except this time we have a negative angle. So instead of subtracting, we're going to add 360. And in this one, we only need to add 360 one time. So negative 150 plus 360, and this is degrees, is equal to, I believe, 210. Is that right? Yeah, 210. And there we have it. Well, my degree measurement's disappearing. There. So these two degrees are coterminal because they differ by the amount of 360 degrees. Now, on this one, this problem here is pretty much a conversion problem. What we're going to be doing is converting the revolutions per minute to degrees per second is what we're doing. But I'm going to go about it a different way. It says a wheel makes 270 revolutions per minute. Through how many degrees will a point on the edge of a wheel move in 5 seconds? Okay, so kind of to draw a little thing. We have a wheel. We have a point on this wheel that is disappearing on me. Let's see. Okay, there. I have to draw a line. We have a point on this wheel that is moving several times. Okay, and it moves 270 revolutions per minute on that edge of the wheel. And so we're wondering how many degrees is that thing going in 5 seconds? So here, this is what we're going to do. So we're going to take the 270 revolutions per minute. First, we're going to change this to revolutions per second. So there's 1 minute in 60 seconds. Okay, so that conversion gives us 4.5 revolutions per second. Okay, now that we have it in revolutions per second, let's go ahead and multiply this by our 5. Okay, so we're going to have 4.5 revolutions per second times 5 seconds, which gives us how many revolutions this thing makes in 5 seconds, which is 22.5 revolutions. Now, there are 360 degrees in one single revolution. So the next step in this is to multiply this by 360 degrees. I'll kind of multiply this out for you. I'm going to show this to you. 360 degrees in one single revolution. So kind of cancels out there just like these minutes canceled out here. And we end up getting 22.5 times the 360, which is this number here in degrees. So this point on the edge of our, let me get my, whoops. This point on the edge right here rotated so many revolutions, the 270 revolutions, but it turns 8,100 degrees in 5 seconds. So a lot of degrees, which is understood. Wheels can turn very fast. All right, so that was actually the last slide on this in this lesson. So I'm gonna let y'all go, and we will cover more of this stuff in class in our homework that we do together. So I'll see y'all later. Goodbye.